Hello, my name is Simranjeet Singh, and this is an overview of my assignment one for COM 251. And basically, this assignment made us do an array-based implementation of a deck, a double-ended queue in Java. And here I'm just going to go through all the methods I wrote. So here, for the data fields, we just need three basically, which is an array of any type, and then private int num items, which is basically the size of the array, how many num items we have. And then here we're going to keep track of the front of the array, of the deck, sorry. And here we just have this suppress warning just because it gets rid of a warning. Eclipse doesn't like us doing this little sneaky way of casting object to any type. And here this is the constructor function in which we make a new deck of any type item given, and then the max size of this will be 5 at the beginning, and then we're going to set num items to 0 because currently it's empty, and the front of the item, the deck will also be 0, right, because the beginning index is 0. And here size will just return the number of items, essentially returning the size of the deck. And then clear, here we just set the number items equals 0, so size will equal 0. Instead of manually changing all the entries, which will, add time complexity, we just do this, and then when we are writing new entries, we're going to override the old entries. So this is a very clean way to do it. And is empty will just return a boolean value of true if the number items equals to 0. We'll need to check this because realistically, hopefully you don't have a negative size array, otherwise you have bigger problems on your hands. And here this is just a helper function I wrote called rear, which essentially gives me the index of the last item in the circular array. This made it easier because I need to calculate this on the fly a few times, so I just wrote this little thing here. So the -1 here is because I want to actually point at the last item, not on the index after the last item. So that makes sure that I'm doing that. And here we have expand. This is a fun one. Basically, we are whenever we reach the maximum size. So essentially, if the deck has 5 items and we're trying to add a 6th item, our array is only of size 5. So what we need to do here is create a new array of the same type of item, and this array will be twice as big. And then what we're going to do is iterate over our current array, and we're basically going to copy over all the items into this new array. And actually, we have this given to us in the slide. I saw this after the fact because I was having some issues because I'd forgotten these 2 lines, which are very important. And what we basically do is get this array front and copy and normalize it. And here, these 2 lines are very important because this items in the array lets the program know that this is the array that we're going to talk about from now on. If we don't have this, the program will still try to add items to the old array, which is already full and giving you a bunch of errors. This is very important. And now again, front is equal to 0, right? Because we normalized it. Now front is back at index 0. And we're just gonna do double max size. And here, add first. So here, this method, first we're gonna check the size. If we reach the maximum size, we're gonna call the expand method, expand as you saw above. And here, front sometimes needs to step backwards, right? Because we're adding an item to the front of the deck. This means that sometimes we need to take the mod of a negative number. For example, if front equals 0, we're going to have front -1, 0 -1, -1, and we're essentially going to be trying to take the mod of a negative number. To make sure that this gives us the right answer, we need to use floor mod. And we write it like this. So if I go here, essentially we're working a circular queue, correct? So if I have an empty queue, it's here, and I want to add an item at the front, we're going to have to add an item at this index. But if I do a mod of a negative number, mod of -1, Java doesn't give me the correct answer. And so I found a solution here on Stack Overflow, which I've linked here in the README file if you want to check it out later. And essentially, there's 2 different methods that were proposed. One is using this formula, which does work, but it's slightly complicated. Another answer basically let me know that, okay, after Java 8, we can use math.floor mod, essentially taking the mod of the absolute value of the numbers, which is exactly what we want to do. And so we get that, so we make front step backwards, and then we're going to add this item at that index, and then we're going to increase num items because we just added an item to our deck. And then add last, very similar. First, we're going to check the size. If we reach the max size, expand. And here you might notice that, okay, we're incrementing num items before we add the item to the deck. This is because if you look up when we're calculating rear, as I said, we're actually pointing at the last element in the deck. And if we increment afterwards, what this would do would override that element with the new value, and we don't want to do that. So what we do instead is first increment. So now we point at the index after the last current value, and then we're going to add the item x at that index. Because if you remember, like, rear is not a static integer value, it's like we're calculating this on the fly. So this basically adds an item at the end. And here, remove first. So first we just check if the deck is empty, then we can't remove any items. All of these will check that first. And then, okay, we just placeholder item. We take the item at the front, and then we basically increment front. So it's going to point at the second item, I suppose. And then when we remove it, it'll point at the new first item. And then we decrement num items, right? Because we took out an item, and then we return that item. And very similar here, we'll remove last. If it's empty, we throw an exception. And again, we keep the item, decrement, and then return the set item. And here, get is a function that, okay, so first we accept an index, and then we want to check, okay, is that a valid index? If it's not, we're going to throw an error. Otherwise, if it is a valid index, we're going to return the item at that index. The way we calculate that is we assume that front is going to be index 0, and index 1 is the next item, and so on. So we just calculate it like this, and we just step forward as many times as we require for the index. Get last basically gives us the last item. Again, we check the size 0, no elements in size 0 deck. Otherwise, we return the item at the end. Essentially peeking at the end because we're not removing it. Very similar. First, again, check size. If it's good, then give the item at the front. And the last method we have here is toString. So basically, gives us a string representation of the deck. Because if you don't have this, it's gonna just hash out bunch of reference like locations, and that's very messy. So we want to have this method here, and essentially the way it does it is, okay, we create a string variable str, open square bracket, and then we iterate over the entire array, and then we concatenate all the items into str. And this little thing, this little line, what it does is it adds a comma after each item except the very last element, because we don't have a comma after the last element, right? So that's one way to do it. There's a few ways to do it. I like this, and then we add the closing square bracket, and then we just return the string. And here we have a test.java which does two tests, so I'll run it again here. And we have two tests, right? So we're gonna test string and test integer. So test string is here, so already 8 minutes, so I'll be kind of quick here. So basically adding a bunch of items at the beginning, at the end, and then we print what the array looks like, and it should look like this, which it does. And then here we're just asserting and we're just checking if, okay, is the beginning Jason, is the end John, and if any of these would fail, we would get an assert and the program would stop, right? And then we get first, so we're just checking. Here we're doing another bunch of operations, and then at the end of that operation we print out the string again, and this should be the result, which here it is. And then this is, we're adding more items, right? If you remember, the max size at the beginning was 5, and now we're adding 2 more elements, so we actually already called the expand method to just make sure that that actually works. And then we do a bunch of more checks, removing items, shifting items around, and then at the end, this should be the output, which it is. The first item Chris and last David. And then we just add one more item at the beginning and just for the sake of it, and then we just check it, and then that's correct. And the next we're basically do the same thing with integers at this point, because again, we had a generic implementation. We want to check with different types. And so we add a bunch of items first, and then here we get 20, 40, 50, 30, 10. Okay. Then we do a bunch of checks. If any of these would have failed, this program would have run to the end. And at the end, we just get rid of all of them, and we get an empty DQ, which is here. So 10 minutes passed, okay, and that was all, I suppose. Thank you for listening.